Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 2, and this lesson, I don't remember what number it is, but it's going to be about system of two equations. So in the last video, we looked at a system of inequality. So remember, that was when we, I'm sorry, I'm not on draw, when we had the graph, and then we had an inequality here that shaded this way, and then one here that shaded this way, and then we found out that this area was where both sets apply. But now we're going to look at equations. And then in the next video, we'll do something even more complicated, a system of three equations. So, yeah, I hate the three equations one. It's not that it's hard, but it takes a very long time, and it's super easy to make a mistake. Like, crazily easy. And it has very dumb numbers, like 3,654 or something like that. But anyways, we're just doing two for now, and that's a little bit simpler. So let's look at how we would solve that. So let's look at an example. Let's say we had 4x plus 3y equals 16, and then that was our first equation. Next one is 3x plus 4y equals 61. I don't know, that just random. I thought I'd switch the numbers. So we could plot these on a graph if we wanted to, and we could see what we're looking for in a system of equations. What we're solving for is the point at which both equations cross at the same point on the graph. And there's three different situations that there could be. There could be one where we have one equation here, and then we have another equation here. And in that case, this would be the point where they cross. That's called, it's just called exactly one solution. And how you know if this was to be the case is if when we go to solve these, which I'll tell you how in a minute, we actually get an answer. If we just get an answer like if we got x equals 3, y equals 5. Obviously that wouldn't be the case here. That would probably be like -1, 2 or something. But that's what would happen there. But there's other situations also. If you have a line here. Oh, great. Let me go off of this for a second. You have one like this, and then you have another one in which the red line is parallel to the blue one, then that would make there be no solution. What does no solution mean? That means A, you get an answer that is just numbers, in which the x's and y's would cancel out, and we would get something like 13 equals 14, which is not true. So that means there would be no solution, because these, if they're parallel, they're never going to touch, so there's not a solution for that. But there's also another situation. That's if we had the blue line, and then we had the red line, but the red line was right on top of the blue one, like the exact same spot. So it's pretty much the exact same line. That would mean infinitely many solutions, or just you could say all real numbers. That's what that would be. So the no solution one would be if pretty much they had the same slope but a different y-intercept. But we are not going to be graphing them to find it out, because if you notice, these aren't in the y equals mx plus b form, but if we put them in there, we could already tell that the y-intercept for one of them was going to be 61, and obviously we don't want to draw a graph that goes all the way up to 61 for the y-intercept, so it's better just to solve. There's two ways to solve, and based on the way that these equations are set up, you might want to use one or the other, but it doesn't matter which one you use. So the first one is substitution. So substitution. In substitution, what you have to do is you have to convert one of the equations to the y equals mx plus b form. That's what you first have to do. It doesn't matter which one you choose, you just choose one of them. And then after you do that, you plug in that equation into the y of the other one. And then you just solve. So let's see. Let's say we just want to make this top one into the y equals mx plus b form. We would have to subtract 4x, and that's all we have to do. Just subtract 4x from both sides. And so our new equation is y... Oh, wait, sorry. Forgot about the 3. So it's still 3y equals negative 4x plus 16. Yeah, and then that means... I was wrong about that before. It wouldn't be 61. It would be 61 divided by 4 for the y-intercept, but whatever. So then you divide by 3, and then let's just erase this, or, well, I'll just write it over here. Oh, actually, yeah, I can just do this. So our new equation is y equals 16 divided by 3. 5.3. We're just going to round to the nearest whole number for this purpose because that will make it better. So let's just do 5. And then that would be here. This would be negative 4/3. There we go. So we converted that one to that. Now what we can do is we have to substitute, that's why it's called that, into the y of the other equation. So we just replace the y here with this. So here's what we do. We first have 3x, that doesn't change, plus 4y. So instead of writing y, we just write negative 4/3 x plus 5, and then equals 6. What we have to do is distribute here. So we have 3x equals, plus 4 times negative 4/3 is, we're just going to once again round to 5x, because that was really 5.3 repeating, but I don't like decimals, and how was I supposed to know if it would do a decimal or not? So, yeah. Sorry, that would actually be minus. If you see plus minus, that means it would have to be minus. And then plus 20 equals 6. So, before we go any further, why do we have to do this? We have to do this because there's no way to solve an equation if you have two variables that you don't know. What we're trying to do is find out what y is, and x and y is. I said it backwards. But we can't find one of the other ones unless we know what one is. Now we know what y is, not the exact number, but we know what equation it is, and it has an x in it. So we know how y is related to x. That's why we plug it in for the y, so that now we have two x's that can combine so we can solve. We will first solve for x. So we can combine like terms. 3x minus 5x is negative 2x. Plus 20 equals 6. You subtract 20, and then you get negative 2x equals negative 14. Divide by negative 2, and then you get x is 7. Because negative divided by a negative is a positive. So we know the x, but we still have to know the y, because we need to have both coordinates to know where on a graph these two lines would connect. So let's do that. All we have to do is plug in x to the equation. So 3 times 7, we're using this one, plus 4y equals 61. So that means we have 21 plus 4y equals 61. Subtract by 21 on both sides, and we have 4y equals 40. Then we would have y equals 10. So at the point 7, 10, these two equations will pass by each other, these two lines. So that's how you do substitution. Let's do another one, because remember I said there's two different ones you can do. And we'll do elimination. So elimination is, sometimes I kind of like the substitution one better, but you still need to know how to do elimination because that's what you have to do for the solving for 3. So let's write this back. So elimination, let's do that. Okay, so remember what I said. Why we have to do this complicated a little bit instead of just solving randomly is because we have two variables and you have to know what one is to be able to solve the other, and then in the end you solve the other one at the beginning. We need to find one of them first, and remember last time we found out what y equals in equations terms. But this time, all we have to do is just find a way to cancel out either the x or y. It doesn't matter which one. And once you do cancel it out, then you can solve for the other one, and then solve for the one that you canceled out. But here, how would we cancel out the x? Let's just say we wanted to do that, if we chose that. You need to find a way to cancel out 3x with 4x. What could we do? Well, if we multiplied this whole equation, that's what you have to do. You have to multiply the equations by something. If we multiplied the top one by -3, we would get -12x up here once we did that. And if we did +4, we would get 12x. And we know that -12x and 12x would cancel out, so that's what we have to multiply by. You could do other things also, but I think that's the most simplest thing that you can do. Sometimes if there's no coefficient on, in this case, probably people would say that it's better to, I don't know, it really doesn't matter, but some people might think that it's a little bit easier to substitute because there's there's not any missing coefficients, which means it would be 1, because if that was the case, then it would be a little bit easier to do elimination, but that's not the case. So we have to multiply all three things by -3 for the top equation, and we'll see how that turns out. So let's just call this the blue equation, and this one the red. So the blue is down here. We would get -12x, -3 times +3y is -9y, and then -3 times 16 is -48. Now, we'll do the red. 4 times 3 is 12x. 4 times 4 is +16y. And then 61 times 4 is 244. Now, all we have to do is combine like terms. We can cancel out the x's. That's why we did that. That's what you're supposed to do. You eliminate them. And now we have -9 plus 16. That would give us -5y. Oh, sorry, not -5y. -7y. What's wrong with this? Ugh. Why won't it erase? Okay, there we go. Okay. Sorry about that. And I don't know what I was doing there. So, like I said, 7y, not -5y. I don't know what I was thinking. I was like mixing it up like if it was, I don't know what I was thinking. I was doing some other combination. So then we do negative 48 plus 244. That's 196. Then you do 196 divided by 7. We get that y is 28. Not good, not good. Why not good is that, remember, we got that y was 10 for substitution. So I obviously did something wrong. See, this is why I like substitution better, because I usually do something, I mess up something. You may have caught my error already, but you can't tell me. So you may want to just skip the video ahead until you hear me talking again, because I can't pause this thing. So I just have to look and try to figure it out, okay? Let's see here. Well, it could be possible that I did something wrong on the substitution one. Okay. Oh, well, one thing is that I rounded on the substitution one, but that doesn't explain it that much because it wouldn't throw the answer off that much. Jeez. Let me see if I typed something wrong in the calculator. 196, 28. Okay, well, unfortunately, I do not have any time to try to correct my work, but at least you know the process. So that's the process, but hopefully you caught my mistake. I don't know what it was, if it was on the elimination or if it was on substitution, but I apologize for that, that I made a mistake, but you just have to make sure you check your math right. I think maybe it was something wrong on the substitution one because I looked at this and I don't see anything that's wrong, but anyways, well, if y was 28, we would then substitute in that for the x. So, or sorry, for the y, and then that's how we find the x. So if we use the blue equation, we could do 4x plus 3. We substitute 28 in for y, 16. And then we have 174. 4x plus 174 equals 16. 16 minus 174 is 158. Let's see if our x is going to be 7. I don't think so. That seems, well, it's going to be something negative. I already can tell. Okay. So we have that x is 39.5. That could have been the correct thing for the substitution one, but I did something wrong. But if this was the answer, then the point at which these graphs or lines connect would be 39.528. That would be it for this video. Once again, I'm sorry for the math error somewhere in here, but unfortunately that might be bound to happen on the next video where I have to use elimination to do the 3 equations, but I'll try to not do that. So thank you for watching, and that'll be it.